through other endpoints around those linear chains.
Absolutely. I feel like I glance at this every time I come into the console, but unless something crazy happens, like I go from 1,000 to 100 or 10,000 to 8,000 online endpoints, something dramatic, this is just that, like you said, quick snippet, quick visibility, easy to see. Don't need to interact with it too much.
Yeah, and it's actually it's been pretty important in the past, right? So like someone makes a network change and all of a sudden like 30,000 of your endpoints are no longer registering. It's a very quick, easy way to hit the big red button, right?
Well, for sure. And I will say, sometimes I've seen concern where we see two people from the same organization, and one of them will see X number of endpoints online and the other will see Y. So I will say, when you're looking at this, this is controlled by your RBAC rights. So it may look different to different people, different permissions. Keep that in mind. Don't get too stressed if you've got different rights than someone else and this looks different for you and them. All right, moving along, still in the homepage, we have our question bar here, which if you've been with Tanium for any amount of time, you know, asking a question, super standard. So here we can start typing, asking all those good questions, getting information from our environment. The one that I see people using more and more, and this one, I guess it's been around for a couple of years now, hasn't it? The search endpoints. It still feels so new to me. In this one, we can just start typing and search, whether it be by IP address, computer name. We can pull up a specific endpoint and view that in single endpoint view. Fun thing about Tanium, we get these in two places. So not only do we get these down here, but up at the top, we get that same question bar and that same search for endpoints, and we can come over here. All right, top navigation. We've got these two. We also have our dashboards and report and quick links. Alex, do you use these very much?
Personally, not as much anymore, but being able to very quickly get to your dashboards and reports, like if I was still out in operational world, right, and I was still using Tanium, I would be using these all the time. I was constantly having to build reports. I was constantly having to gather certain information. This is such a quick way for us to gather that information and get it in front of our screens, right? That's why we put it up there for ease of use, right? Instead of burying it deep, Tinian recognized that a lot of people are using this as a reporting function, right? And building reports and all these exciting things. So this is far and away, in my opinion, the quickest way to access these.
Oh, absolutely, for sure. Be able to, stays there wherever you are in the console. So be able to very quickly jump to the top, pull up whether it's your question, your endpoint, your report, or quick links. And something fun here, I don't use this nearly as much as I probably should, but let's say I want to know something about how do I find what my deployments are. Well, I can just start typing a keyword and see all of the different menu options with having to go through all of the menus. It's a quick link. So I'm like, oh, I want to go to my deploy deployments. I can jump straight there from this bar. So super fun.
Love it.
All right. Now, making our way continuously. There we go. There's my deployments. Let's jump back to the homepage. All right. So making our way continuously across here, we've also got Tanium Ask. Now, again, this is amazing. We had an episode on this. I still can't get over it. Tanium Ask, if we click in here, is your way to interact with our AI agent. We've got prompts that kind of says, hey, here's what we can do. But you can also just start telling it without knowing Tanium syntax, anything. Say, hey, I have a question. How can I tell what Chrome versions are on Windows? You don't need to know anything about asking a question. You can talk to the agent and it will help you create that question, find your results. 10 out of 10. All right. And then we have these notifications here. Guardian. And then just general notifications. Now, this can get overwhelming. I don't want to jump too much into it. These will be different depending on your environment, what you have there. Guardian notifications are basically, think of them as our celebrity vulnerabilities or issues that are just big things that are out there. And these notifications will look at your environment. Oftentimes they're linked to dashboards. They can tell you about stuff that's happening and how it applies to your environment right now. And your notifications in general are going to tell you, again, about real stuff happening in your environment, potential new Tanium releases, new features that might be applicable. Lots of good stuff here. I would not recommend letting these pile up. Just take a quick peek at them every day, mark them as read, and you'll get lots of good info and stay on top of your Tanium game. All right. Moving on, left menu. This is our last little console navigation. So we've got our home page with our question bar, right? Our top menu here we just covered. Left menu. All right, start us off here, Alex. We've got home and then...
And then, Jesh, we have modules, our bread and butter, right? This list is, probably 3 times the size as it was when we first started here. These are all the different Tanium modules, right? Now, depending on your environment, depending on your organization, you may have less, and that's going to depend on RBAC and what services you have. But you can see here, this is a really extensive list. They've done a really good job of...
I think choose how you prefer. All right, and then below that...
Now, this particular menu, I believe it's administration. It's for Windows 11. We could easily create a sensor. So let's head back to the page where this...
Direct connect to your endpoints. We could run down this whole list. We're not going to spend too much crazy time on it, but you're going to have some good services in here that you may want to get jumped over to every once in a while just to see, hey, how is this configuration impacting me? So we have those. And then finally, guide. And remember, 2 ways. Here's our guide notifications up top. We also have them all here. And you can configure as well. How do we receive these notifications? How do we group them? All the fun things. All right, jumping back home, we've covered a ton of navigation, just really quick. Day to day, if I'm saying, what do I want you to remember for today? Alex, what do you want our watchers/learners to take away?
My biggest thing personally is always going to be Interact, right? I love Interact. I love the underlying Tanium technology that all of this was built on, including the natural language parser. Coming from a guy who used to have to work in sims that all had their own syntax language, all had these little tips and tricks that you had to remember, Tanium has been the easiest way for me to gather information in a true production environment, right? By using Interact, you can almost just ask it what you want, right? Like, I want info on operating systems. It'll give you some information back, or at least put you on the right track. Not to mention that question builder, which has been around for so long, but it never seems to get quite enough love, right? Because it's so easy to use, and it's so easy to ask these really complex questions of your environment, right? I need to get information from endpoints that ABC that have XYZ installed, and that could be a question of 10 sensors long, right? And using the question builder is the easiest way for me to, 1, see what I'm doing, not lose track of what I'm doing, make sure the syntax is correct. I see the most successful Tanium users using this.
Absolutely. And just to show how easy this is, I know we're getting a little bit into it, but literally I can start typing keywords: computer name, computer serial number, operating system. What else do we want to get? Do we want to get the IP address.
Mm-hmm.
Right. And now all of a sudden, instead of having to write the question, like you said, I just start typing keywords, it writes it from me. And if I want to get it from my Windows machines, well, let's go is Windows. Oh, Windows. I can type.
Yeah, and just to reiterate, for me this was great because using that interact text bar, right? If you have a pretty long sentence or a pretty long question, you start losing track of what you've asked and things like that. And before here with the builder, before you ask it, you can see this on the right side, right? You can see exactly what you're asking.
Exactly. You track it, you ask it, boom, it's perfect. That is
What
amazing.
about you, Josh?
You know, I think there's so much that you could look at within this, and I get decision paralysis when I see something like this. Where do I go? Right? I think what you said, knowing that you can always come to this question builder and start asking questions to just get information, but then know what your role is, right? You can ignore things that they're probably blocked by our back, but maybe not. You can ignore things that you don't need. So let's say I'm an admin who mostly does patching. Well, don't worry about everything else. Just make sure you know how to get to your patch solution, right? Make sure you're looking at the notifications that come up here because they're probably going to be relevant to you. And don't be afraid to explore. Just start clicking around, start jumping in. The only final one I would say too is these little shortcuts up here if you've been a longer term Tenium user. Being able to be anywhere. I'm over in, we're going to jump back into deploy since we've been there. I want to now be able to jump up to ask a question. Well, I can hit my little shortcut key. This is going to tab me directly there. I can start typing. Or maybe I want to see a report. Again, tab there. I can now start typing in to search for my report. So super fun stuff.
Thank you, Josh. Thank you I mean, this was your idea, right? I love the idea of a Tenium Basics series. People are often asking us for, that's when you need the most help, right? Is when you're brand new. So thank you so much for putting this on today. Can't wait for the next one. Maybe we'll start delving into module specific content, things like that. I'm really excited because this series can go anywhere. So thank you so much for joining us today on Tanium Tech Talks once again. Thank you for joining us for our inaugural episode. Council Microsoft Intune.
Mac devices, Linux devices, those can all run the Tanium client, but they're a smaller subset. And an entity could.
So Tim, you just
mid-cycle ability across.
Would you mind?
See, hey, this extends visibility, it streamlines reporting and improves your asset management. And there's this great little video over here on the side that you content capability, the client secret. Now, this is all information that you sync every. If I go over here to Tanium content, I can see some of the built-in content that we're shipping. So some built-in dashboards and reports that are part of that. So let me go ahead and pins here, all the different Android operating system versions, iOS, what all the manufacturers are for all of these, and all of the models. And what's nice is the things that
and servers,
the computer shell number, but there is a Microsoft Intune side here that's just pulling the attribute device and it gives me a confirmation for that device. So let's say you're managing the device through this Tanium console. However, Alex is managing the device through the Intune console. And so if Alex does a restart device from the Intune console, I want to be able to see that that action was done within Tanium. So I come here to this action history, I see this Intune device action status, and that restart device will show up inside of here, even though it was performed in the Intune console.
Oh, really? That's a good, because I was just thinking that question as you were describing it. So this is not just actions initiated from Tanium, it's also from the Intune side. So it's synchronizing actions from both consoles. Wow.
Yes. Yes, absolutely. So if I want to do something like send a custom message to this device, so I'll just give this.
Oh no way! We can do pop-up messages on people's devices.
Yes, you can do pop-up messages to their phones. So it's a great way, like if somebody is being really lazy about updating their phone to the latest version of iOS or Android, like, hey, you need to update. You can start nagging them with these custom notification messages.
Oh man, that takes me back to the Windows days of like the net command and you could send message. Oh my goodness, yes. This is great. So we got end user notification as a for workstations, right? Now we've got it for phones. Oh, this is great, man. You could have some nefarious fun with that.
So you can see here we sent that custom notification to this device. And then we should start to see that here. I think this device is actually offline, so we're not going to see the action pop up on the Intune side. But to get the idea, now we kind of classify actions in two different manners. We have what we call a standard into action, and we have what's called a high impact action. So if we go back over to my integration console, and I look here under my configuration, you can see all of the RBAC roles that are available. And so there are two specific RBAC roles that you'll need to assign. So by default, a normal Tanium user will not have the ability to perform these Intune actions. So you can grant them the ability to do Intune action user or high impact action user. So what is the difference between those two? So if I go back to my single endpoint view, if I'm doing things like reset passcode or remote lock or restart device, those are just standard actions and something that you might want to grant access to your first or second level support for troubleshooting purposes. The top two are a little bit more impactful, so that we call them high impact actions. So things like wipe device or retire device, which would remove all of the Intune data off of that particular device, those have some consequences on the device. So you may want to limit who has the ability to do a, say, full device wipe or retire your device on those systems.
So RBAC, yes, we ship RBAC with things now. We've been doing that for a long time, but you just have to say RBAC in the episode somewhere, right? And yes, this is RBAC. So I have a question then. So classically in Tanium, we've done things like tagging to define computer groups. So I'm guessing here, like the RBAC, the computer groups that we would manage, in this case, entity groups, device types, maybe there's some kind of sensor that's going to give us some of this data that we can then filter on for these groups to manage the devices.
Yeah, absolutely. And the way that you apply RBAC to the machines that are visible is just like standard Tanium. So it's through what's called management rights within Tanium. And you assign management rights based on computer groups. You create computer groups based on queries that you do within Interact. So all of this data needs to be exposed, needs to be available within Interact. So I can do something similar, like give me a computer name and operating system from all entities. But we've got a few things that we can kind of filter this on now. So I can say, where the provider type contains Intune. And so this will give me all of my Intune devices that I've synchronized over. Now, keep in mind, earlier I showed you that you had the ability to set up multiple Intune connections to different Intune tenants. And so what we often see is that customers will want to grant rights to specific machines based on which Intune tenant that they were connected to. That is possible to do as well. So I'm going to do provider name here. And you can see here that 9 of my devices came from this particular provider name, and 1 of those devices came from the other provider name. So I can create computer groups for a specific provider name and assign that as management rights for my users. And so they'll only have visibility and potentially actions for those specific devices.
So if I'm a global enterprise and I've got a distributed help desk and I need certain tenants of Intune to be managed globally, regionally, things like that, we can accommodate all that with the filters. Another question. So forever in Tanium, we've had sensors like is Windows, is Linux. Do we have something like is iPhone or something like that that we can pull out just like it looks like we can say like OS operating system contains iOS or something like that, but do we have a way to like these other sensors? What's available there?
We have a new one. It's called entity type. So entity type in this particular case will bring back that this is a mobile device. And so that allows you distinguish those. But also stay tuned. We're still doing development work on this, and so there is going to be a lot of additional sensors that we are going to be releasing in future releases, all the way up through the end of the year. So stay tuned, and you'll see a lot more different types of data come in that you can also use to further limit your groups for RBAC.
Tim, that's absolutely fantastic. I keep thinking back to these days. You know, we preach on the show a lot. We preach single pane of glass, things like that. But I think back to about a decade ago when I was working behind the help desk, and I'm like, man, this would have been really useful other than opening my 16 different tabs and trying to administer all this stuff. But hey, with Converge coming up right around the corner, can you give us any teasers on like what labs are in the works for this Intune integration?
There's actually a great lab specifically for integrating Intune with Tanium. So you can sign up for that. It will cover this capability as well as other capabilities. So sign up for that. There will be more information on the main stage about this integration as well. And there will be some additional breakout sessions. So look for breakout sessions on the Microsoft partnership, and you'll get to learn more information about this as well as all of our other Microsoft integrations.
Yeah, I heard that code language, like through the end of the year. We're recording this in October, so we all know what that means. We're going to hear more in November in Orlando. We hope we can see you there. So Tim, this is wow. Whatever. Anything else? I know we've covered a lot of ground here.
We have.
Yeah. What are you hearing from customers who are doing this already? I know we have some early adopter type customers. What kind of feedback have you gotten from them?
Like the biggest feedback is that they love that they're getting that single pane of glass. They love they're getting that visibility. It solves a big reporting challenge that they have today. The other thing that I did not necessarily cover, we do have the ability to then take this data and synchronize this data into ServiceNow through our asset integration. So that is there if you want to now bring in your mobile devices. So it's actually pretty shocking to me that most of our customers are not putting any mobile devices inside of ServiceNow at all. And so it's a big visibility gap for them that they're not currently tracking. And so this gives us a way to bring that data into ServiceNow. One lesson that we learned is that we wanted to bring these devices in, but we learned very quickly that the customers don't necessarily want these devices into ServiceNow immediately. And that was the problem we had initially is we turned this integration on and like all of a sudden additional like 4,000 devices showed up in ServiceNow and they're like, what? So we
Incredible stuff. I've been at Tanium 5 years, so I've watched just iteration after iteration.
Well, hello there. In this video, I'm gonna go over about 30 tips or so of agent teams, basically everything you need to know to just have a pretty good understanding of what it is, how you should use it, when you should use it, and some kind of good use cases that I've found using agent teams. Now, there's a lot of different orchestration solutions out there, but I always like to use kind of the ones that were developed by the tooling itself. And I've been having a lot of fun using agent teams for work and also just for my personal stuff. And I thought it would be a really good video. Now, if you haven't seen my 50 tips of just general Cloud Code video, I recommend you to watch that. But this particular video is about agent teams. So without further Further ado, let's get right into it. So what is agent teams and why should you use it? So at a high level, an agent team is essentially an orchestrator of subagents, but there's a big difference between subagents and how agent teams work. And we're gonna get into that. Now, if you don't know what a subagent is, at a high level, you can just think of it as another Cloud Code instance that your main Cloud Code instance spawns. Oftentimes, when you create a subagent, it usually has this like colored text. That's how you can tell, at least in Cloud Code, that you are spawning a subagent. So in this quick example, I essentially had a task and I had my architecture and backend and front-end subagents essentially be all coordinated. This is my agent team. Now you can have any agent team, any composition of it. Essentially, it's like unlimited, right? I have this one here for like code writing, and I have like another one for like writing, which helps me gather context. It helps me edit. It has like a writer. So there's a bunch of different things you can do. But the high level idea, the main concept is that you have one leader who is kind of the orchestrator, and you have many different teammates. And you could have any teammates that you could imagine. Now, before we move on, one important thing is that all of this kind of operates around a set of tasks. And then the concept is you have the leader who has all the tasks, and then they spawn all of these agent teams, and then the agents do individual tasks. Now, one of the most important things about team agents, unlike just using sub-agents, is that the teammates talk to each other. Let me try to demonstrate. Can you work on the next set of tasks? Let's do like 5 tasks or so at a time so I can get a clear picture of all the different things you guys are doing. For this project, I kind of like created a bunch of tasks to save some time, but ideally in a real world instance, you would probably have a plan mode and then you're just planning up some tasks. You're essentially working with the main agent, the orchestrator, to create a set of plan for your different sub-agents. Now, one key thing here that you need to know is that because the agents talk to each other, unlike sub-agents, the context is somewhat shared. It's not fully shared. The way they actually do the sharing of the context is they just use like messages to each other. So you're not actually getting all of the context from the main like orchestrator. It's really just the messages. So that's like a high level tip that you need to think of. If you ever feel like your sub-agents in your agent team is not having enough context, then you need to ask the main agent to send the additional context, or you need to add more context into the tasks that you're creating. So as you can see here, like my context gatherer, my editor, my writer, they're all kind of like talking to each other. And that's kind of the point. They're sending messages to each other, not strictly sharing the context, but just sharing what is needed for each other. So the next big tip is that once you have a bunch of sub-agents, you can talk to any teammate. Now this is kind of messy and very crazy. This is the split pane view. So I'm going to show you guys how to do that, but let me bring this other view so it's easier to see it. Can you run the agent team to do another pass of editing? But yeah, essentially at a high level, you can talk to any of the teammates, you can talk to the orchestrator. So essentially you could guide any of the agents for like if you created another Claude instance, it's basically the same. Now, the most important difference between a sub-agent and an agent team is that the context is completely protected between the sub-agent and the main agent. The sub-agent doesn't know anything that the main agent knows unless the main agent sent an initial so like seed of stuff. And the sub agent, its only job is to like essentially do some side effects or send information back. Now the agent team, as I mentioned, they talk to each other, they coordinate each other, and they share a common task. And the orchestrator can control any of these sub agents. That's like kind of the big difference. So for tip number 4, essentially, if you need just some very quick results, use a sub agent. If you need collaboration, use an agent team. Tip number 5 is that compared to just using a single instance of Claude Code, agent team just costs more. You're basically doing parallel work. So if you're not used to or already doing like multiple Claude instances, then the usage might outpace what you're used to normally. So the question obviously is, when should you use this? Well, like, what is it really good for? So in my opinion, the best use case for agent teams so far has really been when I needed to accomplish something, some task, that needed like various different tasks to be completed in different domains. So a really obvious example for full stack is this example that I had, which is essentially a front end, a back end, and an architecture. And in this particular example, it even created like multiple front ends, and because it recognized that they were in like different places. So it really speeds up the execution. Now, another really good use case, Ali for me is for writing. So I have a context gatherer, I have an editor, and I have a writer. The editor essentially scores a bunch of things and suggests edits. The context gatherer like essentially gathers context from my like local vector memory. And a lot of my writing I do with this flow. Before, what I had to do was I had to kind of sequentially do these things, and it took a lot longer time. But now with agent teams, I'm able to kind of do all of this all at once. And then they actually help each other, because sometimes rather than writing the entire thing, it might go grab a context for like a part of my writing, for example. So tip number 7 is you should probably skip using agent teams for sequential work. This is actually kind of a good example right here. Front end 1, front end 2, front end 3. Like most of the time, if you're working on the same like pages, you probably don't want to have multiple front ends, because then like they could kind of conflict with each other unless you use like work trees or something like that. All right, so well, hello there. How's it going, everybody? Today, we're gonna go over my 50 Claude Code tips. I've been working with Claude Code basically every day for about 6 months now, and I feel like I've learned a ton of things. And yes, I am one of those engineers that are basically not writing code anymore. I'm still in Claude Code like 12 hours a day, actively pair programming with Claude Code basically, and reviewing a ton of code. I still read every single line of code. That's actually my biggest bottleneck right now, the reviewing of the code. But I thought it would be great to show you kind of the best tips that I've learned along the way. And these are kind of tips that I wish I knew when I was first getting started. We're gonna start off with some foundation stuff like setting up, very quick setup stuff, a little bit about like Claude.md rules, like what you should put in, what you should think about, and kind of some of the advanced stuff for later. But without further ado, let's dive into 50 Claude Code tips. So I got my terminal here, and I just have some slides behind to tell you guys what I'm doing. So here is the foundations that I mentioned. We're gonna cover getting started, keyboard shortcuts, some essential like slash commands, and a little bit of a deep dive into the Claude.md. So let's get started. All right. So for tip number 1, you want to run Claude Code in your root directory of whatever project you're working on. So for example, I have this Pomodoro app that I'm like kind of been working on. So I'll type in like Claude here, and that's essentially how you get started. And you really want to do this because later we'll talk about this, but if you have rule files or any kind of setup, the initial root directory is where Claude is going to zip up the context into that first token. So if you ever wonder why you had a bunch of tokens used, even though you just opened up Claude, this is probably the reason why. It's because Claude's getting your project ready. All right, so one of the first things that you want to do is run /init like that. And what this does is Claude will go and look at your code base and do an analysis of your code base, and then create that initial Claude.md file in the .claude directory of your code base. Now, there is like different directories that you could source from. Like you could have a global one or like this one. But yeah, at a high level, what this is doing right now is it's just looking at the code base, looking for the architecture, and then basically it's creating that Claude.md. All right, so it just finished. It does take some time, and as you can see, it's kind of going and saying, oh, this is like a Next.js 15 app. It's like a portfolio site. But yeah, it's just going over high level things about this particular project. And then you could just essentially hit yes to commit that to your .claude. So this is like really important for new projects, so I highly recommend you to run it. All right, so the tip number 2 is that Claude.md file file that we just created, it kind of runs on a hierarchy. So if you go to memory/memory, you could kind of see right here that there is a checked in memory, which is the current root directory. And then there's a user memory. This is like your global one. So that's like in your tilde.claude/Claude. So you could kind of choose between it, but it's really there so you can know what the core rule that the Claude code is operating on right now. Looking at the claude.md that Claude just created, like this is a pretty good one to get started, right? It just has like, you don't want it to be too large. It's like very small, right? I think around 300 lines is about a decent place that you want to aim for. And to be honest, going larger is fine, but just remember that every time you increase that initial context window, you're going to use more tokens, first of all, but also the more bloat you have in your context, the less likely the AI will do exactly what you're trying to do. All right. So for structure and what you should be thinking about putting into your claude.md, I just opened another project. This one is my anime Pomodoro. This is an iOS app. So I wanted to show you a little bit more examples, but basically the things I like to put is like high level technical architecture and the requirements, you know, like what is the project? Like that's kind of important. And then you want to give it like some domain context, right? Like, oh, it's using Swift UI, and I probably would add high-level architecture and like kind of the file path and things like that. And just some of the high-level design patterns, like you'll see, like all of that should go in here. And then one of the important thing is kind of having your build flow, like your validation flow. And this is like kind of where my build and validation is. So you can see that I'll like build the Xcode and then build a project, make sure things compile. Just having this loop of validation is so amazing because the AI will just be able to self-improve and keep going until it fixes itself. So like if you are ever in that situation where you just like ask Cursor to do something or ask some AI code agent to do something and it just doesn't work, a lot of that gets resolved when you fix the validation. And validation, I think as a side tip, is probably one of the most important topics that you should really think about when you're thinking about trying to build good AI agentic like coding systems or any workflows, is really what is the validation loop? Because that will dramatically improve how good your AI will be. All right, so let's go to some keyboard shortcuts. And the reason why I even have this entire section for this is because if you're going to be in Claude Code all day,
there are a couple of reasons why incoming network traffic to a service may not reach the underlying pods. And in this section, we will want to talk about how to troubleshoot a service object. We'll learn how to identify the root cause of a failure. And then we'll also talk about some techniques on how to fix the underlying root cause. Let's have a look at some techniques that I use to identify an issue with service connectivity. First of all, I usually try to list the service with its specific name and have a look at the service type. Now this one is of service type cluster IP, so I would assume that traffic can only reach the service from within the cluster. Now then I usually try to actually make a call to the service either with the DNS name of the service or the IP address, depending on what type of service it is. As you can see here on the second command in the output, we cannot really connect to the service, which is indicated by connection refused. So something is obviously wrong with the configuration of that service. Now there's a command we haven't talked about yet. This one is called the get endpoints command. So the get endpoints command will render all the virtual IP addresses of pods a specific service should be able to route traffic to. So if you see none in the column endpoints, that usually indicates an issue with connecting to those pods. If you do see the virtual IP addresses listed or the endpoints, then those are the pods that will receive the traffic. Now, there are two sources of misconfiguration that are very common. Number one, it would be the label selection. So make sure that the label selector uses the same key value pair as we assigned them to the pod that should receive traffic. And then also make sure that the target port matches with the container port that we exposed to the pod. If one of those options is incorrectly configured, that would usually mean that the traffic wouldn't be routed properly. Now, it's also possible within your Kubernetes cluster to instantiate network policies. And network policies we'll talk about in a separate section of this course. However, just to talk about it now in the context of a service, make sure that the pod selector will not select any pods and block traffic to those pods with the help of a rule defined by a network policy. And the way we can identify that is by having a look at the pod selector column that applies to a network policy. So make sure that says none at this time, or identify any network policies that could potentially block traffic to the underlying pods. Now, just coming back to the actual pods that will receive traffic, if you configured the label selection properly, and if you configured the port mapping properly, there's still the possibility that the application doesn't run properly in the underlying container of the pod. So you can see here in the first command, we have a pod where we couldn't pull the container image, so therefore the application wouldn't even be functional. So that's still a possibility in that context. Make sure that at least the pod exposes the status running. Let's have a look at the situation where we already have a service setup that routes network traffic to a set of pods. And in this case, you will actually find that we cannot reach the underlying pods because there's some sort of issue with the service configuration or the deployment configuration. So in this scenario, we will want to inspect the existing objects and then figure out what's wrong with them, fix them, so we can route the traffic properly. So before we can have a look at anything more in detail, let's have a look at all the objects in a specific namespace. That is the namespace I already set up for you, Y72. We will find a service named web app. We'll have a deployment that controls two replicas, and we want to make sure that we can actually reach the underlying pods from the service. You can see here the service is actually of type cluster IP. So we would usually try to reach that service from within the cluster. So let's give it a try. One way to figure out if it's actually working as expected is to create a temporary pod. And here we are going to use the name web app. That is the name of the service. We are running a wget command. We also have to make sure that we're going to try this out in the same namespace here. So Y72 needs to be used. And let's see if we can reach the underlying service here. And it looks like connection is refused. So that didn't work as expected. So let's talk about some techniques that you can use to identify the underlying issue. One thing I usually like to do is to have a look at the endpoints. And for that, we can simply apply this to the same namespace that we used before. You will find that we have a single endpoint here. In fact, it's a mapping between the service name and the endpoints. And you can see that the endpoints column says that no endpoints could be found, meaning we could not establish the connection from the service to the underlying pods. So something is not configured correctly in this case. So let's have a deeper look at the service and see what we can find out. We can simply run the describe command against the service. And this service is called webapp-ny72. And what we should find here, type is cluster IP. Also wanted to point out that there are two attributes that are of importance for the configuration and correct functionality between the service and the underlying pods. One is the selector, so key value pairs assigned to the service that will select the pods. So we'll check that first, and then the target port here. So make also sure that the target port is the same as the container port assigned in the pod template for the deployment. Now let's also have a look at the deployment here and see if that is actually configured as expected. So we'll remember the label selector should be run myapp, and then the target port that maps to the container port should be 3001. Deployment, the deployment is also called web app. And let's see what we can find out. So if we look at the container definition here, you'll see that the container port is actually different, 3000 in this case. So this is already not configured correctly. And then lastly, we also have a assignment for the labels where we have app, web app, but that doesn't match with the run equals my app. So we can either decide to reconfigure the service or the deployment. One of those configurations could work. So let's go ahead and simply change these configuration of the service. It might be a little bit easier. So we have to make sure that we'll use port 3000 and we'll use the label assignment app web app. Let's see if we can make this happen. So target port will change right here. So this should become port 3000. And then in terms of the selector, that should be app web app. And I think that should probably do it. Let's see if that works as expected. So we edited the service. Let me clear my screen. And now we are going to have a look at the service again. So let's have a look at the endpoints. And let's see if we can find the corresponding endpoints. And you can see under the column now, the two different pods that we route traffic to are now listed with their virtual IP addresses and the container port. So it looks like we could establish the correct connection here. So let me run my test here again to see if we can reach the underlying pods through the exposed service. And optimally, we should see we fixed the issue. So just to summarize, when we have a configuration of a service that works together with a deployment or just a single pod, make sure that label selection is correct and also the port assignment is correct.
Well, hello there. Hello there. All right, so today, calendar, essentially. So the first thing is audit, the second thing is aggressively block, and then the last thing is defense. So that should free up a bunch of time, and that's kind of the foundation of being productive. You need to find the time. If you say, I don't have time for this or anything like that, then you've already lost. You need to find the time or make the time for the things that you think that is important for yourself. So once you have this foundation, the next tip I would say is do not confuse motion for progress. Oftentimes when I see a lot of junior engineers like doing things, they'll just do a lot of things. You know, fix a bug there, do a small tweak there, just do a bunch of little tiny little things. And they might feel like they're super productive, and maybe early on they are, but the higher level you go, these like lower hanging fruits is not what counts, and it's not really the things that will move them. So the saying is, don't mistake motion for progress. You really want to think about the things that you're doing and making sure that they're high quality, high impact, and be able to be very intentional on the things that you choose to work on. So how do you go about choosing like these important things? Well, I usually have this kind of gauge of like, how difficult is this project and what is the potential impact of this project? And I do the same thing for like YouTube videos. I think about the video and I do some research and see what is the TAM, what is the addressable market for this video, right? You really want to be intentional in the things that you want to accomplish, because not every task, not everything that you want to do will have the same impact. So if you want to be intentional about being productive and you want to move the needle in some whatever project you're trying to do, make sure you're trying to pick the best and most important things to do. Now, the reason why I mentioned that is it hard or not, because the next big tip for me, at least as an engineer, is you should try to block off long, uninterrupted focus time of coding. That's probably a really important tip. For me, I always try to do 2 to 4 hours minimum at a block at a time for my coding sessions. And you know, there's this whole like meme about staff engineers not coding. I don't really believe in that. I try to code as much as possible and do all the other stuff that like a staff engineer needs to do. But the reason why I'm able to do that is because I strategically block off my calendar in a way that I have these 2 to 4 hour chunks of time, at least in the morning. Now, the next tip is related to this, and it is to match your energy to the task at hand. So if you followed all the tips so far, then you have more time in your calendar. You would have done the step of blocking off certain segments for coding or deep focus. Whatever deep focus task that you need to do, the most challenging thing, you need to do it when you usually have the most energy. And for me, that's in the morning. For some people, it might be middle of the day. Whatever works for you, engineer your calendar in a way so that you reserve a solid chunk of time to get meaningful and hard work done. The best things in life, in my opinion, are usually on the opposite side of hard things most of the time. So I always kind of gauge my week and go, did I do some of productivity, like a detriment to productivity? The point is, there's probably a lot of things in your life where you can outsource, whether that is cleaners to help you clean. And for work, it might be asking for help earlier for a certain project if you don't know something. Learning how to ask for help is a skill in itself, and learning how to outsource things is also a skill in itself. You need to audit your life too, and your spending, and obviously, and see, can I afford to automate this? Can I afford to hire this extra things? If you don't do that exercise, then you're gonna just be stuck doing those things and you won't be able to free that time. It's not really about just freeing the time, it's also about accelerating the things that you want to accomplish. Now, the next thing has to do with scaling, in my opinion. The thing about productivity for me, the things that I think have high
don't need to solve 500 leak code problems to pass technical interviews. I know that sounds crazy, but hear me out. Now, there's this idea floating around that the only way to get hired at a top tech company is to grind leak code for months, solve hundreds of problems, and basically dedicate your entire life to memorizing algorithms. And yes, some people do that, but most of them still fail interviews. And the ones who pass, they're not passing because they solved more problems. They're passing because they understand something that most people don't. Now today, I'm going to show you how to pass technical interviews without the endless grind. Now I'm talking about a smarter approach that actually works and one that got me hired at Microsoft without solving 500 random problems. Here's what most people do when they start preparing for interviews. They go to LeetCode, they see 3,000 plus problems, and they just start solving. No plan, no structure, they're just picking random problems and hoping that something sticks. You finish 50 problems and feel productive. You finish 100 and think you're making progress, and you hit 200 and you're convinced that you're ready, but then you walk into an actual interview and you see a problem that you've never seen before and your mind goes completely blank. Why? Because you weren't learning, you were memorizing. And memorization doesn't transfer. The second an interviewer changes one small detail about a problem that you've seen before, you're lost. You didn't learn how to think through problems, you learned how to recognize specific questions and regurgitate answers. And let's be real, grinding 500 problems is exhausting. It takes months, it destroys your motivation, and by the time you actually get to the interview, you're so burnt out that you can't even think clearly. Now, I've talked to engineers who spent 6 months grinding leak code every single day and still failed their interviews. It's not because they weren't smart, it's not because they didn't work hard, but because they were preparing the wrong way. Now, there's a better approach, and it doesn't require you to become a leak code monk. Here's the secret that top candidates know. Almost every coding interview question is based on a small set of repeatable patterns. We're talking maybe 15 to 20 core patterns that show up over and over again across thousands of problems. Think things like 2 pointers, sliding window, fast and slow pointers, merge intervals, binary search variations, depth first search, breadth first search, dynamic programming, backtracking, and a handful of others. Once you understand these patterns, once you really internalize how they work, and when you apply them, you can solve problems you've never seen before. You're not memorizing answers anymore, you're building a mental toolkit that lets you break down any problem into something familiar. Now think about it this way. If you solve 500 random problems, you might see 500 different variations. But if you learn the 15 to 20 underlying patterns, you realize that those 500 problems are just different flavors of the same concepts. Let me give you an example. The 2 pointers pattern alone can solve dozens of problems. Things like finding pairs that sum to a target, removing duplicates from a sorted array, checking if a string is a palindrome, and a lot more. Once you understand that pattern, you don't need to memorize each individual problem. control. You just recognize, oh, this is a 2-pointer problem. And you go right into that approach. Same thing with sliding window. Once you understand how to expand and contract a window across an array or a string, you can solve problems like finding the longest substring without repeating characters, maximum sum of a subarray, or size k, etc., right? Different problems, but the same underlying pattern. Now, this is why 100 well-understood problems always beats 500 rushed ones. Every time, I've seen it countless times. Interviewers don't care how many problems you've solved. They care whether you can think through a new problem in real time, because that's what you're actually going to do on the job. And that ability comes from understanding patterns, not from memorizing solutions. The engineers who pass interviews at Google, Meta, Amazon, they're not smarter than you. They just learn to recognize these patterns and to apply them effectively. This is the skill that you need to focus on developing. Now let me break down the most important patterns that you need to master. These cover probably 80% of what you'll see in technical interviews. So first, 2-pointers. This is where you use 2 indices to traverse an array or a linked list, usually from opposite ends or at least at different speeds. It's great for problems involving pairs, sorted arrays, or linked list cycles. Second, sliding window. You create a dynamic window that moves across a sequence, expanding or shrinking based on certain conditions. This is perfect for problems involving continuous subarrays or substrings. Third, fast and slow pointers. So 2 pointers moving at different speeds, typically used to detect cycles in linked lists or find the middle element. Fourth, binary search variations. Not just basic binary search, but modified versions for rotated arrays, finding boundaries or searching in infinite sequences. Fifth, depth first search and breadth first search. These are essential for tree and graph problems. DFS goes deep before exploring the siblings, whereas BFS explores level by level. Sixth, dynamic programming. So breaking problems into overlapping subproblems and storing solutions to avoid redundant work. Now, this one's harder, but once you get it, you can solve optimization and counting problems very easily. Seventh, backtracking. So exploring all possible solutions by building candidates incrementally and abandoning paths that don't work. So this is great for permutations, combinations, and constraint satisfaction problems. Think something like Sudoku. Now there are more. You have things like merge intervals, topological sort, union find, tries, monotonic stacks, right? But if you can nail those core 7 patterns, you already cover most of the core ones you're going to see in interviews, and you're already ahead of most candidates. Now the key here is to learn one pattern at a time. Don't try to master them all simultaneously. Pick one pattern, understand the concept deeply, and then solve 5 to 10 problems that use that pattern. You really need to understand why the pattern works for those problems. Then you can move on to the next pattern. Now, this is so much more efficient than just randomly grinding, because instead of solving 500 scattered problems, you're doing maybe like 100 to 150 targeted problems that each reinforce a specific skill that you're actually going to retain and remember. Now, here's something that most people don't realize. Interviewers aren't just evaluating whether you can solve the problem. They're evaluating how you think, how you communicate, and how you handle what happens when you get stuck. Now, I've seen candidates who got the optimal solution but still got rejected because they couldn't explain their reasoning. And I've seen candidates who needed hints, didn't get the perfect solution, but got hired because they demonstrated clear thinking and strong communication. Now, when you're in an interview, talk through your thought process out loud. Ask clarifying questions before you start coding. Discuss the different approaches in their trade trade-offs and explain why you're choosing a particular data structure. Walk through your solution with examples, right? This is something that leak code grinding doesn't teach you at all. You're sitting alone, solving problems in silence, and you never practice what the actual interview skill is, right? Which is communicating your thinking in real time. And if you want to get better at this, you need to do mock interviews, right? Practice with friends, use free platforms like Prepped, or find a study buddy. Even your mom sitting in front of you, even just someone there is going to be helpful. Now, the ability to think out loud while coding is a skill, right? And like any skill, you have to practice it. Don't expect to show up to the interview and do this, perfect the first time you've tried it. So with that said, here's how I'd approach interview prep if I was starting from scratch. First, make sure your fundamentals are solid, right? You need to know basic data structures, arrays, linked lists, stacks, queues, hash maps, trees, graphs, heaps, you name it, you need to understand that. You also need to know big O notation and be able to analyze the time and space complexity. Now, if you're rusty on this stuff, spend a week or two reviewing this before you start solving problems. Second, learn the core patterns one by one. Don't solve random problems, be deliberate. Pick a pattern, understand it conceptually, solve 5 to 10 problems that use that pattern, and then move on. Third, do mock interviews regularly. Start doing them early, so maybe after you've done 20 or 30 problems, not just right before your interviews. You need to practice communicating your thinking under time pressure. Fourth, review and reflect. After every problem, ask yourself, what pattern was this? What did I struggle with? How can I recognize this faster next time? This reflection is what actually turns practice into real learning, where you're improving, you're not just doing the same thing over and over again. Now, if you're consistent, to be honest, you can be interview ready in 6 to 8 weeks here. Most people online are going to tell you 6 months, but if you do this with the right approach, I promise you, and I've seen this with hundreds of people, that's all it takes to get ready. Now, that's way less than the 6 months that some people spend grinding aimlessly. Now, the key is focused, deliberate practice, not just accumulating problem counts. It doesn't matter how many problems you've done if you can't solve something new that you haven't seen before. So that's how you pass technical interviews without grinding leak code for months. Like I said, it's not about solving 500 problems. It's about understanding the patterns that those problems are built on. It's about learning how to think through new problems in real time and about communicating your reasoning clearly. Now, the resource that I personally used to prepare for my interviews and the one that helped me get hired at Microsoft was AlgoExpert. I'm going to go on the platform and I want to show you exactly why I use this because it follows the approach that I just broke down with you. Okay, so this is AlgoExpert. And again, this is actually what I used when I was preparing for my interviews. Now, not only do they have Algo Expert, which is kind of similar to LeetCode in terms of the types of coding questions, but a lot more structured, as you're going to see, but they have Systems Expert, Front-End Expert, ML Expert, Infra, iOS, Blockchain, etc. So no matter what
Hey guys, Greg here. Let's solve minimum size subarray sum, LeetCode number 209. So we're given an array of positive integers called nums and another positive integer called target. Now we need to return the minimum length of a subarray whose sum is greater than or equal to the target. And if there's no such subarray, then we need to return 0. Okay, so let's look at this first example here. So given the target of 7 and the nums array of 231, 243, well, the smallest length subarray, that sum is at least the target of 7, is 43. So remember, a subarray is any contiguous block of elements. So this is a subarray, this just on its own is a subarray, this is a subarray, so continuous elements. The smallest length subarray where the sum is at least the target would be 43, and the length of that is 2. So for this approach, we'd want to use a sliding window technique, and we'd want to keep track of the current sum of our window, and we'll initialize that to be 0, and we'll also keep track of the minimum length that fits our constraints here. So we'll just set that at infinity. And now we'll use a sliding window. So we set L and R both equal to 0. And R's job is to basically expand the window. So if we're right here, it would look like this window. And L's job would kind of be to contract that window. So it's going to keep making it smaller. So here's how we do that sliding window approach. So R says, okay, we're looking at this and we are going to increase the sum by that amount. So our sum goes up by 2, or if this array was called A, it would basically go up by A at R. Okay, is our sum fitting our constraint? No, it's not. It's not at least the target. So we need to expand the window. To expand the window, we move R over, and that means we're looking at this part of the window. We increase our sum by the array at R, so it goes up by 3. 2 plus 3 is equal to 5. No, that is still not enough. So a couple times, we're going to expand this. This goes up by 1, 6, still not enough. enough. And now when we get over here, our sum is going to go up by 2. So we now have a sum that fits our constraints. This is at least equal to our target of 7. Okay, cool. So we can see that we have a better minimum length than infinity. And so we actually got a minimum so far of 4. But we're looking for a smaller one. So can we get a smaller one? Well, we'll try to contract the window. So we'll move L over here, and then we're now looking at basically this part of the window. Before moving L over, we need to make sure that we lose the sum that we had at L here, because you're going from using this number to now not using it. So our sum must go down by that amount. And now we are looking at this subarray, and the constraint is not hit yet again. So while the constraint's getting hit, we are contracting the window, and while we're not hitting that constraint, we need to expand the window to try and do so. So we will move over R, we'll get a sum of 10 right now. That is currently at least the target. Okay, what is our window length? It is going to be 4. By the way, you can always calculate our current window length with the calculation R minus L plus 1. These are indices, so it'd be 0, 1, 2, 3, 4, 5. We'd have R is 4 and L is 1. So 4 minus 1 plus 1 is equal to 4. This window length is 4. That's just how you would calculate that. And currently we're hitting our constraint. We didn't find a better min length because this is also 4, but let's try and find a better one. We decrease our sum at L, so we're going to lose that number, and then we are going to slide this over here. We are actually still hitting our target, and our window length would be 3, so we found a better min length of 3. We are going to keep trying to find a better one. So can we do better than 3? Well, we move this over and this would go down to 6. Okay, no longer hitting our constraint. We're going to move over R. We will add 3 to get up to 9. Okay, cool. We're hitting our constraint yet again. We have a length of 3. That's not any better. Can we get a better one? If we move L over here, we would go down by a value of 2 to hit a sum of 7. Great. We are actually still hitting our constraint, and the min length is actually better. This is a length of 2. So we found one of 2. Can we find one with just 1? Well, we would move L over and we'd see now we have a sum of just 3. Okay, not hitting our constraint. We would move R to the end of the array, and that is when we complete. So as you can see here, we would end up with our min length of 2, and that's a great approach because this is going to be big O of n, basically because we just move L and R through the array, and the space complexity of that is actually going to be O of 1. A sliding window does not take up any space. Okay, so we're going to get our min length, which is initialized at infinity, and this is how you would do that. Our current window sum is just 0, and we'll initialize L as 0, and we'll actually use a for loop over R. So we'll do for R in the range of the length of the numbers. So R's job is to expand the window, so our sum is going to go up by nums at R, and then while we're hitting our constraint, so while our sum is at least the target. In that case, we have a current valid window. We need to write this down to see if we got a better one. So we'd set min length equal to the minimum of itself and the current window length, which we can get by R minus L plus 1. So if we found a better window length, then we would write that down. Otherwise, we would just keep it as it was. Now, can we find a better one? We want to contract the window, aka move L forward. And so before we can move L forward, we need to lose that value we're going to lose. So sum is going to go down by nums at L, taking it out of the window, and we need to move L forward. So this is going to keep running while that window is valid. We'll just keep finding better ones as long as we can. And then when we get out, we will no longer be hitting that constraint, and R is going to work to try and find that again. After that is all done, that will be done in O of n time because L and R just go through the array, and we can go ahead and return our min length if the min length is less than infinity. Or if it's still stuck at infinity, that means we never hit a valid window, and so otherwise we would return 0. So this approach is going to give us a big O of n time complexity, and it doesn't take up any space. As you can see, we're not storing anything. You can see it beats 88%. That really doesn't say what the graph shows, but that's fine. Anyways, here's our code, guys. Drop a like if this was helpful. I hope it was, and have a great day. Bye-bye.